So good afternoon, everyone. Let us continue with our discussion of this subject on sustainable engineering concepts and life cycle analysis. So let us continue with our discussion on the fourth week lecture notes. So in this week, we will be basically going to the LCA methodology and also try to understand the inventory analysis as well as the impact methods and also the ISO, that is International Standard Organization frameworks on it basically in a good detail, in depth. So let us start. So yeah, so this is the lecture 16, LCA detailed methodology. So why the LCA term or the concept of LCA has emerged? Why it is required? What is its necessity? So, for example, if we take two bulb cases, one is compact fluorescent bulb and one is incandescent bulb. So I hope you know what is the difference. So basically, the fluorescent bulbs basically both are light bulbs. They give light, but the way of giving light is different. So fluorescent bulb is basically the photons when they are excited from ground state to excited state. So upon when the photons release energy, okay, so when it releases energy from the excited states and comes back to the ground state, so it emits some radiation, okay. So those radiations basically it has a certain wavelength, and that wavelength basically gives the color. So that is how the compact fluorescent works, okay. That is the mechanism, and compact is basically it works on a certain range, certain compact range of wavelength. And the incandescent bulb is basically it emits light due to heating, okay. So the coil, the tungsten filament, it is heated to a certain degree, and as a output of that, so it emits light. And as we have discussed in previous classes, so it emits about, like, the efficiency is about very less, it's about 5%. So 95% energy is wasted as heat, only 5% heat and other forms of energy, only 5% is emitted as light. So the efficiency is very less. So now if we were to compare, okay, so between compact fluorescent and incandescent bulb, so if we were to ask which is better, okay, is compact fluorescent bulb worse, equal, or better than the incandescent bulb? So how will we answer that? Okay, so there comes the the necessity or the requirement of life cycle analysis. So basically, as we studied in the last class also, the LCA study consists of four steps. One is defining the goal and scope. One is life cycle inventory stage. Okay, so it includes all environmental input and output. So that is basically the elementary flow. Okay, so we will be studying about that. And one is the life cycle impact assessment. That is the third step, where we understand the environmental relevance of of all the inputs and outputs. And the last is the interpretation of the study. So what is the outcome from the study conducted? So the life cycle of a product, in this case, or like for a certain product, so all the processes associated with the product, wherever and whenever they might occur, are considered, okay, in the life cycle. So these are the processes. For example, the main standard processes for every product. One is resource acquisition, one is manufacturing, one is distribution, one is use, and the last is end of life management. So inside the first process, which is resource acquisition, so there will be various unit processes, okay, inside that. So one will be extraction, one will be transformation, okay, raw material collection, etc. So that is the unit processes. In the second process of manufacturing, there will be unit processes related to assembly, packaging, etc. In the distribution process, there will be unit processes which will be related to storage, handling, transport. In the use of in the process of use, okay, that is the main goal behind the development of the product. So there will be unit processes related to maintenance, repair, reuse. And in the end of life management process, there will be unit processes such as collection, recovery, valorization, recycling, landfilling, incineration, etc. Okay, so therefore, we can say that LCA is an accounting exercise. Okay, so we will be able to account the various inputs and outputs that has been received in the development of the product. And there are basically two types of there are two parts. Okay, one is environmental impacts and one is environmental intervention. So environmental impact is basically perturbations of natural cycles by and environmental interventions. Okay, so perturbation is basically a small change, okay, in the cycles, okay, which is caused due to environmental intervention. So it is basically, if you go to the technical definition, perturbation is a small change in a physical system, most often in a physical system and equilibrium that is disturbed from the outside. So outside, that this is the exciting factor, which is the environmental intervention. Okay, so that is working from outside. And if we talk what is environmental intervention, that is basically the change in state of natural environment due to the human activities. Okay, so it is the, in fact, related to the it is a function of human activities. And LCA basically, so it is accounting for all environmental interventions associated with life cycle of product. So that is the definition. Okay, so it will account for all the environmental intervention which is associated with the life cycle for the product. So now, if we go into the life cycle inventory, okay, so that is the second step. First is the goal and scope. Second is the life cycle inventory. Third is life cycle impact assessment, and fourth is interpretation. So if you go into life cycle inventory, we will find that as we just studied, so it will mainly have the a certain number of processes. Okay, so most standard processes for a product is product are resource acquisition, manufacturing, distribution, use, and end of life. Okay, and this boundary, okay, so this boundary basically, which is shown in dotted lines, so that is basically a system boundary. It indicates that only these processes are required for the for that for the system which is required for creation of the product. Okay, so these processes are required in a system which is necessary for the development of a certain product. So that is basically called the system boundary. Okay, and for this to occur, okay, there has to be some inflow and outflow of various types of resources, okay, as well as emissions. So inflow will be the natural resources and output will be in the form of emissions, okay, in the form of environmental intervention. Okay, and also there will be a functional unit assigned to the system processes, which basically will give the so depending on which we have to find out all the inputs and outputs and relate them in order to carry out the life cycle analysis. So this inflow and outflow of this elements, we can say this these things, these items to be elements. Okay, so this input of natural resources, output of emissions, and environmental interventions, so these are basically elements. And this flow, okay, so there is inflow of inputs and outflow of outputs. So we can basically call that in a larger sense to be like we can say everything in a larger sense to be elementary flow. Okay, so we'll come what is elementary flow. So this inputs and output movement, inflow of input and like going out, like inflow and outflow of output, inflow of input and outflow of output, it is known as elementary flow. Okay, so this input that can be natural resource extraction, so that can be in the form of iron ore, crude oil, water, wood, solar energy, land use, etc. And outputs that can be firstly in terms of emissions. So emissions also can be categorized in air, water, and soil. So if we talk about air, the most common ingredient is the carbon dioxide emissions, which is basically responsible for global warming. So apart from that, there is sulfur dioxide, PM, which is particulate matter, and VOC, volatile organic compounds. For case of water, there is PO4, that is phosphate, NO3, nitrate, and in case of soil, it can be pesticides and metals. And in the case of other environmental interventions, there can be radiations. Okay, so there can be high frequency electromagnetic waves, okay, so which can be very harmful, that may cause cancer also. And it can also have heat. Okay, so because it is an energy, it can result in heat, and also it can create noise. Okay, so that is also a pollution, type of pollution. So now let us see what is a functional unit and reference flow. So basically, functional unit, as you can see here, so it is a given amount of function to which all inputs and outputs are related to. So basically, it is the requirement of the product. Okay, so what that is basically a tangible value assigned to the requirement of the product. Okay, so for example, we need a certain for example, we need the bulb. Okay, so for what purpose, what tangible value we need the bulb? Say for example, we need 10,000 lumens of the working of bulb. Okay, so that is basically a specification. So what is the requirement of the product? Okay, so why we need that product? So that is basically given in a unit which is called a functional unit. Okay, so product comparison is the functional unit or comparison basis. Okay, so basically the comparison between two products, it is in terms of functional unit or some comparison basis. However, in many cases one cannot simply compare product A and B, as they may have different performance. Okay, so the product may be similar, okay, but in terms of performance they may be different, so it can be very difficult to compare in such types of products. For example, if you compare milk cartoon and a returnable milk bottle, okay, so milk cartoon, which is basically say for example Amul, okay, so Amul can Amul milk, okay, so it is sold in cartoon, like the actual one, Amul Taza and all. And the returnable milk bottle is the new ones, okay, so like the this badam milk and all types of pista milk, okay, so they are being like they are being sold in bottles, so you can return them, okay. So although both are milk, okay, so it is very difficult to compare both, okay, because they are having different processes. Like one is like process involved for making the cartoon will be different for the process as compared to the process which is involved for the making of the bottle, okay, so it will have differences. And the way people use bottle because it can be used many times, right? So therefore it may become so therefore we can say that maybe comparing two ways of packaging and delivering 1000 liters of milk is a better option. So instead of comparing milk cartoon and milk bottle, it may be better to compare two ways of packaging or two ways of delivery, okay, 1000 liters of milk, because that will be a more equivalent way of this one, equivalent or similar way of comparison, okay, so it will be a proper justification to the life cycle, okay, otherwise it may go haywire, okay. So, continuing the lecture. So, if we talk about the life cycle of a light bulb case, so we can see here that this, as I told you, so this is a system boundary, okay, the dotted line, and inside that we have various processes like resource acquisition, manufacturing, distribution, use, and end of life, okay, and each process has some subunits which are known as unit processes, okay. So, for example, resource acquisition has extraction and transformation. Manufacturing has unit processes of like they will be using various elements such as glass, okay, tungsten, copper, steel, aluminum, argon, electronic components, plastics, mercury, phosphorus. So these will be the unit processes which will be required for the creation or the assembling of the bulb, okay, in a assembly chain. So that is a that is a broad unit process, okay, which will be a function of all these elements, okay. And the like the for example in the light bulb case it can be two types, as we for our comparison, one can be incandescent or one can be compact fluorescent. And in the case of distribution process, it can have unit processes such as packaging and transport. In the case of use, it will be having unit process of electricity, okay, so that is why that is the purpose of lighting, okay, and that is the bulb's function, basically lighting. And in the case of category of end of life process, we will have unit processes such as disposal, okay. Disposal will basically can be in terms of landfill, okay, or incineration, that is burning. So if we now go into the inventory for a light bulb, okay, so that is the data collection, data extraction, or data record, okay, stock of data which is available for the analysis. So there we have to consider these five types of properties. One is the product system that is modeled by the analyst. Say for example light, this is the light needs glass, cardboard, electricity, okay. Second is the functional unit, okay, fu. So that is basically the service, okay, the specification of the service which we require, okay. For example, providing 700 lumens for 10,000 hours. So lumen is the SI unit of SI unit of light intensity, okay. So that is lumen. So if we require 10,000 hours of 700 lumen intensity light, so that is a functional unit, okay. So that is basically the specification or the service provided. Third is the reference flows, okay, so that is data collected by analysts. So basically reference flows refers to the amount of inputs, okay, which will be required to satisfy the functional unit, okay. So reference flow will be basically the elementary flow that is required to maintain the or achieve the functional unit target, okay. So then there will be unit processes which we just discussed. So it can be measured, calculated, or estimated data, and it has two It can be either primary or the data can be both primary as well as secondary. So primary data is the basically the specific goal which is intended for the particular product, and secondary data is basically a general product, general data, okay, generic data. So we'll find this out when we discuss further. And fifth is the elementary flows inventory. Okay, so that is what is coming and what is going, inflow and outflow. Okay, inflow of input and outflow of output. So if we properly define then therefore if we properly define the functional unit, so for the two products, okay, incandescent light bulb and compact fluorescent light bulb, so what was the primary function? So that is the specific function, okay, so just lighting. And what is the secondary function? This is a general function, okay, so it will be heating, obviously, okay. So incandescent light bulb, it will have a much higher heating. As I told you, 95% energy is like it is not used, it is released in form of heating, okay, only 5% efficiency. And also compact fluorescent light bulb, definitely, because if you are exciting to a higher photons to a higher degree, it will have some sort of heating, but it is much lesser as compared to incandescent bulb. And apart from that, there will be creating an ambience, okay, so that is the purpose of bulb, okay. So ambience basically is like character, assigning a character and atmosphere of a place. So this is a general definition. So like it will make the place, it will give a certain characteristic to the place, okay. And now if we see here, it is showing what is the difference between functional unit and reference flows, okay. So functional unit is the specification or the service which will be provided, okay. So for example, in both the cases, our target is as we saw in the last slide, our target was 700 lumens for 10,000 hours. So providing 700 lumens for 10,000 hours was the functional unit, because it was the service that was required to be provided, or specification. And as I told you, lumen is the SI unit of light flux, okay. Flux is basically the amount of light rays passing through an area, okay. So it is basically light density. And what is the basically unit of power? So here if you see, so functional unit was basically the service provided. Reference flows were basically, as I told you, what 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 flow is needed, what elementary flow is needed for achieving that functional unit, okay. So what is needed, okay. So in case of incandescent light bulb, in order to provide 700 lumens for 10,000 hours, we will be needing 10 bulbs, each of 600 kilowatt hour of electricity, okay. And in the case of compact fluorescent light bulb, we will be needing only one bulb, providing each like one bulb which will provide 14 kilowatt hour of electricity, okay. So that is the requirement to achieve this functional unit. So that is basically the reference flow. So it will be different for both the bulbs. And one of the key parameters here will be the lifetime watt per lumen ratio, okay. So that will basically define the efficiency and longevity of the product, or as well as the quality, okay. So now if we go further, so life cycle inventory, as I told you, so these are the elementary flows, okay. So inflow and outflow of inputs and outputs respectively. So input will be, it can be in terms of iron ore, it can be like, it will include various materials such as iron ore, crude oil, water, wood, solar energy, land use, etc. And outputs will be definitely in form of some emissions, okay, such as carbon dioxide, sulfur dioxide, particulate matter, volatile organic compounds, phosphate, nitrate, pesticides, metals, okay. So now inventory may count hundreds of different elementary flows, okay, because we will be needing like we'll be needing a high number of we'll be having a high number of requirements, okay, for creating the product, okay. So it can have hundreds of different elementary flows, which is very hard to interpret, okay, because we will be basically always considering the main ones, okay. But in the process we will be needing various other items which we don't take into account. Say for example, we may be needing a scissor, okay, for some certain certain purpose, but we'll definitely, our mind will not like we will not think of scissor when we are talking about a light bulb, right? So but it may be required, maybe in the process of wiring or somewhere, okay, or like cutting the filament, okay. So like that, there are hundreds of different elementary flows possible, okay. And brain can simultaneously consider only up to 7 independent parameters. So brain has the ability, like as per research, it has the ability to only consider only 7, only up to 7 the most important independent parameters, okay. So what is done actually in the life cycle inventory is, we'll neglect those processes in the process tree which contributes less than 0.1% of environmental load. Okay, so it is not possible to take into account, okay, infinite numbers of elementary flows. Okay, so our product may have infinite number of sources. So how will you how will you take into account everything? Okay, so that is not physically possible. Okay, so therefore we always neglect those processes in the process tree which contributes to less than 0.1% of the environmental load. So that is neglected in the life cycle analysis. Okay, and for this life cycle analysis, okay, so we'll later see the timeline, how it was what were the advances, okay, how when were the advances made. Okay, so there we will find that one of the initial as well as most accepted, okay, initial and most accepted comprehensive database for life cycle analysis has been found to be the EcoInvent database. Okay, so this is one of the most highly accepted and very detailed, standardized, and globally accepted life cycle analysis database, and that has been developed by Switzerland basically. So there are various organizations which took part, okay, which contributed to the formation of this EcoInvent database. So basically, if we talk, like, this is a central database, okay, the EcoInvent database, and that was basically uh, for that database to exist, basically it was a contribution of 6 institutes. Okay, so these institutes were EMPA SG, FAL, PSI, ETH LTC, ETH UNS, EMPA DU. Okay, so these names are in, as you know, they are in German. Okay, because in Switzerland most of the Swiss speaking people are German. Okay, so if we take the English names, so EMPASG basically it refers to the Swiss Federal Laboratories for Material Science and Technology, and SG is basically a place, like it is located in this place, okay, Saint Gallen. The FAL basically it denotes Swiss Federal Research Station for Agroecology and Agriculture. PSI basically refers to Paul Scherrer Institute. ETH LTC basically refers to Swiss Federal Institute of Technology Laboratory for Technical Chemistry. The ETH UNS basically refers to Swiss Federal Institute of Technology Natural and Social Science Interface, and EMPDU basically refers to Swiss Federal Laboratories for Material Science and Technology, which is located in Dubendorf. Okay, this is a place. So how these institutes played a part? Basically, FAL. Okay, so it contributed to the central database, the databases associated with agriculture. Okay, similarly, the Paul Scherrer Institute, PSI, it supplied databases associated with energy supply, which were in terms of fuels, electricity production, and heat production. The ETH LTC, it provided database related to basic chemicals. The ETH UNS, it basically provided database related to transports. The EMPADU, which is located in Dubendorf, so it provided database related to metals, construction materials, woods, basic chemicals. And EMPA-SG, so it provided database related to plastics, paper and board, basic chemicals, detergents, waste treatment, etc. Okay, so like this, the accumulation of all the databases, okay, so that resulted in a creation of a central master database. Okay, and that resulted in the creation of the, or the publication of the EcoInvent, the the inception of the EcoInvent database. Okay, so that is a very world standard database which is accepted all over. And you can, for more information, you can visit this website for finding more information about them. Okay, so now if we go further, okay, so there, how the life cycle is analyzed. Okay, so basically we have as we just discussed, we had system boundaries. Okay, inside that we had processes and unit processes. Okay, and for achieving the process we had some flows of input and output which were elementary flows. Okay, and now the question is how the life cycle is calculated. Okay, so it is calculated in such a way that the elementary flows, okay, so basically the processes don't have any life cycle, this one like the processes don't result in any life cycle issue. Okay, the life cycle issue is created due to the inflow and outflow of all the materials and ingredients. Okay, that is the basically the elementary flows. Okay, which is resulting in the creation of life cycle, which is resulting in the requirement of the life cycle. Okay, so that's why the elementary flows, which are the inputs and outputs. So after going through this, okay, so we we select the various impact categories. Okay, so we select the various impact categories which is associated with those inputs and outputs. Okay, and then we try to find a single score out of the impact categories which we have selected. Okay, so these impact categories can be of various forms. Okay, like it can be global warming, it can be ozone layer depletion, it can be land use, it can be natural resource depletion, it can be acidification, it can be eutrophication, it can be photochemical ozone generation, it can be human toxicity, it can be ecotoxicity. Okay, so all flows may not result in all the above. Okay, so based on the certain flow, we have to select which are the impact categories it can affect. That is why it is called impact, which are the categories which it can impact. Okay, and based on that we will be putting some certain weights. Okay, and putting certain weight for certain category, and thereby we'll try to find out the single score which will give the analysis value. Okay, so that is the basic idea or the basic mechanism. Okay, basic mechanism of basic outline or basic the basic methodology of how life cycle impact is calculated. Okay, so in this regard, there is a very famous method. Okay, that is the impact 2002 plus method. Okay, so that was a method which was released in 2002. Okay, so it works on this methodology itself. So impact 2002 plus was released in 2002. So it is a midpoint and endpoint method. Okay, so as we just discussed, so these categories are basically impact categories, and the final score. Okay, so that is basically calculated from a damage category. Okay, so it is a midpoint and an endpoint method which assesses several midpoint impact categories which are here, and the three like actually it is four, the three areas of protection of human health, ecosystem quality and natural resources, as well as additionally climate change. Okay, so these four categories at the endpoint level. Okay, so like based on the impact categories, it's find the ultimate damage categories, and by putting adequate weights to all the categories, it finally finds the n value. Okay, so the single score which will give the life cycle value. Okay, so that is how it worked, and the work has been published in Joliet, a study done by Joliet and others in 2003. Okay, so in that structure, if you see, so this is the general overview of the structure of the impact assessment method. Okay, and the LCA results are characterized to produce a number of impact category indicators. This is the category, as I told you. So this is the LCI result. Okay, the inflows, elementary flows. So that will be based on this. We will select the impact categories. Okay, so what are the flows? What are the results of life cycle inventory? Will be basically finding the impact categories. Okay, and the indicators. So here these are the indicators. Okay, and the LCA results are characterized. Okay, so we will be finding the impact category indicators, and according to ISO, that is International Standardization Organization, one must document the environmental relevance of each indicator. Okay, so we have to find out the environmental relevance. Otherwise, it is not required. If the environmental impact is less than 0.5%, it is not necessary. Okay, so we'll be documenting the environmental relevance of each indicator by describing the link to the endpoints. So how is it like that can be found out by relating to the endpoints. Okay, and endpoints can be selected by the practitioner as long as the reasons for including or excluding endpoints are clearly documented. So it has to be precise. Okay, more will be the precision, more will be the clarity, more will be the quality, better will be the results. Okay, so this is the inventory LCA result. So that will give the idea of the elementary flows. Based on this, we will be selecting the midpoints for the impact category indicators, and based on that, we will find out the endpoints, and putting certain weights, we will get the actual score. Okay, so that is how the environmental mechanism works, and and that is what was suggested. That is actually what was suggested by Guet Coop and Sprinsma. Okay, so this is a schematic overview of the methodology proposed by Guet Coop and Sprinsma. The environmental models for each compact impact category are extended up to endpoint level, as we saw in the last this. So they have even generalized this all the endpoints. Okay, so in this case they have generalized it to be human health. Okay, because it is related to disease and all. Okay, seawater level, respiratory disease, cancer. Then this extinction of species, dying of forest, so it is ecosystem. Okay, and reduced resource base, it is related to resources. Okay, so That is what they have done. The environmental models for each impact category are extended up to endpoint level, as the impact category indicators that relate to the same endpoint have a common unit. Okay, so this is a common unit. Okay, these indicators can be therefore be added. Okay, because it is related to a common unit of human health. These all are having a common unit of human health, so they can be added. Okay, and added to human health. Okay, so similarly, ecosystem as well as resources. And in the case of ecotoxicity, the endpoint is ecosystem quality expressed as potential disappeared fraction of plants. Okay, so that is a separate indicator. Okay, endpoint indicator. So like this, we have to calculate. That was suggested by Goetkop and Sprijnsma, and thereafter putting standard weights, adequate weights. Okay, so which is more important, we'll put a more weight. Okay, which is less important, we'll provide less weight, and thereby you will calculate the score, which is the interpretation. Okay, so like this, these two people had suggested. Okay, these two scientists had suggested, and this is the environmental mechanism of performing the LCA according to them. So here it was found that the choice of the impact assessment method depended largely on the audience address. Okay, so which is the impact assessment method which we'll be doing? So that will be depending largely on or what are the endpoints, impact midpoints. Okay, what are the basically categories, impact categories and endpoints. Okay, so that will be mainly dependent on the audience address. Okay, so therefore it has been we can say that implementation plan of LCA, for that we have to find a goal, why use LCA. Then we have for that we have to find the scope, which applications, how are results reported, and to who will do it. For the interface with in the category of interfacing with our organization, we will be basically working on eco design, strategy development, product declaration, benchmarking, EMS, which is environmental management system, process improvement, and LCC, which is life cycle costing. And based on that, we will submit the data, or we'll be submitting the data to LCA experts. Okay, so these experts, okay, so that experts can be based on the audience address. It can be designers, it can be product managers, as well as it can be EMS or environmental management system specialist. Okay, so if the LCA experts based on the audience, if they're designers, so they will only consider the eco indicators. Okay, for them the eco indicators are the most important. If the experts are product managers, okay, so they will take into account aggregated scores and some details. Okay, so that is requirement for them. But for the EMS specialist, that is environmental management system specialist, they require all the data. Okay, all details is required for their calculation. So that is how the impact assessment method works, and it mainly depends on the audience. Okay, so for example, are they designer, are they product manager, are they EMS specialist? For everyone, the requirement of data is different. So let us see what are the LCA benefits and drawbacks. Okay. So the definition of LCA, so it is an assessment method which gives information in terms of quantitative, comparative, environmental, product, service, or corporation, and life cycle. Okay, so comparative is basically relative results, quantitative is a value. Okay, environmental in terms of all environmental aspects, product, service, or corporation, that is of the system. And life cycle from cradle to grave, that is from birth to death. Okay, birth is basically the inception, and grave is basically the finish. Okay, end of life. So the key features of LCA basically, so it requires complete life cycle plus all environmental aspects. Okay, so that is why we can say like it gives a global perspective. Okay, and it is complex. Okay, so that requires a lot of transparency, because it is very complex to otherwise identify where we are going, which are the indicators, which are the choices. Then the depth of detail of LCA varies. Okay, so it varies depending on the goal of the study, and it also depends on the standards and guidelines required, which have been taken. And the resource needs in terms of time, money, software tools, all of them can vary. And the choices are unavoidable. Okay, so we have to take choices. Okay, so that is subjective. Okay, we have to consider, we have to find out which is required. Okay, which are the impact categories required, which are the midpoints to consider, which are the endpoints to consider. Okay, which are the, as we discussed just back, which are the common units we have to consider, what are the weights we need to assign. Okay, so all of this is subjective. So choices are unavoidable, we have to take choices. uh, it may so happen that we make the correct choice, okay, but they are unavoidable. We have to like, so that depends on our quality of our choices, okay. The result depends on the quality of our choices, and also to a certain extent to luck also, okay. So have we been able to make the correct choices? That is also a question, okay. So that basically depends on our capability, and there is no scientific basis to reduce those choices, okay. There is no scientific say code or any no scientific reference, okay. There is no scientific reference to which you can rely upon, okay. So basically there is no reference. You have to take choices, and that's why there is no hard and fast uh, value choices that go from this data to a single score, because we need the final value, right? But to get that final value, the accurate value, so there is no hard and fast value choices, okay. We have to take the long way, and we have to depend on our capability and the quality of the choices which we are considering, okay. So now, in one of the main problems of the drawbacks of the LCA is the problem shifting. Okay? So problem shifting is basically the shifting of problem in a domain from one aspect to another. Okay. So initially there was a separate problem. Now we have solved that problem, but in a way we have also created a new problem. Okay. So how that is happening? Let us see. Say for example, in the domain of time. Okay. In time domain, we are recycling products that contain heavy metals. Okay, so we can say that recycling is a good thing, okay. It is a good it is a good aspect, okay. It is a good habit, okay. But if we are containing, like if we are recycling the heavy metals, okay, so they also in return they're releasing some emission, okay. So they're basically releasing some emission to air. So that is again a nuisance, okay. So that we don't want, okay. So that is basically a problem shifting. We are creating a solution, but in return we are also creating a problem. Similarly in space domain, so we are exporting hazardous waste. We are creating problem in other substances. For example, in gutters, okay. So these are basically roof channels which carry rainwater in our houses. So basically we are replacing the zinc gutters by PVC, okay. PVC gutter. PVC stands for polyvinyl chloride, okay. So similarly to other environmental compartments such as incinerating waste that contain heavy metals instead of landfilling them. So because landfilling is becoming a problem, so what we are doing is we are just burning them, okay. So if we burn, so we are removing the waste, okay. But that waste has been directly emitted into the air, so that is again creating a new problem. So similarly to other types of problem, we are reducing acidifying emissions by increasing GHGs or greenhouse gas emissions, or if we say also if we say we are creating to other consumption patterns. We are shifting the problem to other consumption patterns, like we are spending savings from fuel efficient cars on holiday flights, okay. So we are spending this savings. So basically we are saving from fuel efficiency, but again we are spending that on holiday flights, so that again is releasing CO2 basically. So that is basically the idea of problem shifting, okay. So in this regard, if we see the evolution of environmental preoccupation, that is thinking, okay, evolution of environmental thinking, how it has evolved over time. So if we see here, we'll find that basically initially the idea was to restoration. Idea was about restoration, that is basically cleaning up, okay. So basically firstly polluting everything and then cleaning up, okay. That with time it evolved, and then the idea was to reduce the emission, okay. That is basically end of pipe. So that basically suggests that it is an approach to pollution control which concentrates upon effluent treatment or filtration prior to discharge into the environment, as opposed to making changes in the process giving rise to the waste, okay. So effluent is basically liquid waste or sewage discharged into a river or the sea. So if we, for example, if we say in restoration or cleaning up, we actually discharge the liquid waste or sewage into the river or the sea, and then thought of cleaning up, okay. In however, in a case of emission reduction or end of pipe, so what we did is just before discharging, okay, at the last step, we try to filter, okay. We try to filter or treat the water so that this waste or sewage is not discharged, okay. So at the end point, we tried to removed it or filtered it, okay. And that was the idea. But after further evolving, okay, further evolution, we have found a way of pollution. We have now we are basically focusing on pollution prevention, okay. So pollution prevention is basically not creating the waste at the first place. Okay, so that is basically this one, making changes in the process which give rise to the waste. Okay, so why to even create that waste? Okay, let us make changes so that even that waste also is not created. Okay, so we don't have to think about treating that at the last stage. Okay, so that can be achieved through these ways. Okay, so one is through cleaner production. Okay, second is through DFE DFS. So DFE stands for design for environment, DFS stands for design for sustainability. The third way is through green chemistry. Okay, adopting green adopting environment friendly practices in various domains which require where chemical reactions are involved. Okay, and like finding environmental friendly practices there. And fourth is through life cycle management, which we are basically studying. Okay, so these are some of the ways. Now, how to assess the environment? Okay, so what are the tools which help us in environmental assessment? So basically there are four types of tools. One is RA, which is risk assessment. One is EIA, which is environmental impact assessment. One is SFA, which is substance flow analysis. And the last is, as you know, it is LCA, life cycle assessment. So the object analyzed for every tool is different. For RA, it is basically installation and substance. For EIA, it is basically the new activity. Okay. For SFA, it is basically the substance, and for LCA, it is basically the product and service, which is the system basically. So the scale for that will definitely vary. So for RA, it is basically local or regional. For EIA, it is local. For SFA, it can be both local or it can be both regional or global. So it is a life cycle of substance. Okay, basically. And for global, for LCA, it is always global. Okay, so it is life cycle of product or service. Okay, and based on that, we can also say about the aspects considered. So RA basically it considers about ecotoxicity. The EIA basically considers about variables. The SFA basically considers about no effects. Okay, and the LCA basically it focuses on the multiple effects, as you have just studied the various elementary flows. So if you see here, it is like how to model this. Okay, LCA, it is the modeling of reality. So if you see, there are three types of models. One is economic model, one is technological models, and one is environmental models. Okay, so the economic models is basically the system definition. Okay, the function and the product system. Okay, so the processes involved and the hierarchy of the processes involved. So that comes in the system definition. So function to product system. In the technological models, it basically it is dependent on the inventory. Okay, it is basically dependent on the data. Okay, the records. Okay, so it is dependent on production inventory. Okay, and that is dependent on the elementary flows inventory. Okay, so what is the inflow of elements and what is the outflow of elements? That is the elementary flow. And the environmental model, so based on, so this inventory requires the system. Okay, so system definition and economic model, so based on that only we'll be able to find the inventory model which is a technological model, and based on that only we will get the environmental model, which is the impact assessment. So impact category indicators, which are the midpoints as we studied in the impact 2002 plus technique. So those are the impact category indicators, and from that we will be finding the endpoints as well as the interpretation, which is basically a single score. Okay, so we will find that single score, we'll try to find a single score. So that is the environmental model. So what are the limits to this model? Okay, so the main limit, okay, main limitation of this model is it is the SS impacts basically they are basically the potential impacts. Okay, so the assessment of the impacts are basically potential impacts. Why potential impacts? Because they are not real impacts. Okay, so the hazard has not happened. Okay, we are just thinking of the hazards. Okay, so we are just calculating. We are just being uh, what to say, we are just basically being apprehensive of what may go wrong. Okay, so that's why they are not real impacts and they are exceeding of thresholds. Okay, so we are overestimating. Okay, we are taking some conservative value, and the safety margins or risks are very high. We are considering more safety margins or risks than the actual. Okay, so therefore they are not real impacts. Okay, so that is basically due to relative expression of impact scores related to a reference unit, which is the functional unit, integration of environmental data over space and time, inherent uncertainty in modeling of impacts, and the fact that some impact categories clearly represent future impacts. So that's why I told you we are overestimating the impact. Okay, so that is therefore it is more than the real original impact. So that is one limit, and the second limit to the model is it is only for environmental aspects. Okay? Social and economic aspects can be analyzed through some other tools. The inventory, okay, so inventory has a limitation that not all processes and flows can be considered, and also the data quality can be an issue. Okay? So for data quality, you need a large for high quality data, you need a large inventory. Okay, so more will be the data, better will be the quality of the flow of the data, of the processes, of the flows, and of the analysis. And the impact assessment has some limitations such as chosen impact categories. Okay, so that they can be weak categories. Okay, we may miss the strong ones, and we can only know later on. Okay, so that will not give the actual result. And there will be available characterization models. Okay, so that models have some can have some limitations, and it is relevant on the data. Okay, inventory data, is it relevant? Okay, so that's what I told you. So we can take some unnecessary data, and we can also miss some important data. Okay, so those are some limitations to the model. So let us see about the history of LCA now. So in early 1990s, the in early 1990s, like in California, there was some decisions, okay, which had some narrow perspectives. Okay, so how it was narrow, let us see. So in early 1990s, California had a policy goal of reducing emissions of air pollution by encouraging the adoption of zero emission vehicles, okay, ZEVs. And the idea was to introduce 2% of the fleet by year 1998 and 10% by 2003. Okay, so that was the goal, to replace 2% of the cars with ZEVs, zero emission vehicles, by 1998 and 10% by 2003. And that was that could like the idea to achieve that was through using vehicles which were battery powered. Okay, so they wanted to power the vehicles through battery of lead acid, okay, containing lead acid, PV. And these vehicles had no tailpipes, so basically they did not have any exhaust. So they did not have exhaust to release the smoke. Okay, so these were the qualities of the zero emission vehicles. So it was found, however, that there was a study done by Lev and others, okay, in 1995, and the study was published in Science. Okay, so Science is a very famous journal. So in the study, it was found that this policy would not achieve its intended goals. Okay, so that was a very big limitation of that policy, that decision in California. So let us see what were the problems basically. So it was found that the cars were fully powered by batteries. Okay, so that should have been, according to the people in California, that should have been a boon. Okay, so but it was not a boon. Okay, it was not a benefit. It was in itself a problem. Okay, because batteries of this type needed to be recharged. Okay, so obviously battery means recharging, and recharging happens with electricity. Okay, so that is obvious, and that electricity production has air emission, because most of the electricity generation now also is now also most of the electricity generation is dependent on thermal electricity. Okay, thermal power generation. So thermal power directly results into air emission. So although we are talking about green electricity, which is currently very famous, that is renewable source, but mostly the energy source, electricity source generation is mostly thermal. Although with the advent of solar panels and everything has come, but still the majority of the electricity which is generated is basically dependent on thermal power plants. Okay, thermal power plants. So also at the similar, like that was one of the main reason. And other from that also, at the time batteries were lead acid. Okay, so they contain lead acid. So this heavy batteries, for This so lead was a heavy element, right? Heavy, yeah, it is considered heavy metal. So these heavy batteries for battery only power, and the large amounts of lead needed. So it required a large amount of lead. Okay, so that resulted in significant manufacturing recycling emissions of lead. Okay, so that is again a hazard. And more lead was released than without ZEVs. Okay, so without ZEVs, which was like what was the release, even higher release was found. Okay, like in the case of ZEVs, where lead was released at a higher concentration, obviously because that was used in the batteries. So if we overall, if you looked, if we could have looked, if they could have looked at the neutral perspective, so it was found that an LCA could have pointed this out, but was not performed originally. So if they would have done the LCA at that point of time, so they did not, they could not have, they might, they should not have made this decision. Okay, but they did not do this, so that's why this problem arose. So 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 therefore we can say that the LCA was very like, that is the necessity of the LCA in today's world. So let's see how it like let us see about this inception. Okay? So the life cycle cost analysis is a subset. Okay, so cost focus is a big factor in infrastructure management. So everyone will say like main thing is money in industry, and the initial LCA work was focused on energy. So it was mostly focused on energy, and the first attempt to do something similar to LCA was in 1969, where a first multi-criteria study was conducted on Coca-Cola. Okay, so how it was conducted, let us see. So there, people had tried to find out the choice. Okay, they tried to select the choice between glass and plastic for the container. They tried to select the choice between internal and external container production, and they wanted to find the end of life options. Will Should it be recycling or one way? So the result, it was found that plastic bottles was best. Okay, and that was very much contrary to expectations. Okay, so people thought that glass would be the better option, and obviously, if you think in a uh, if you think in a prima facie way, so we would feel like the glass would be better, but as a result, it was found that plastic bottle was the best contrary to expectations, and this study was never published. Okay, so because of that, the questions of validity therefore occurred, which has been a running theme throughout, and this led to the calls by scientific community for a standardization process. Okay, so because of this happening, okay, so the scientific community, they wanted the standardization of a process. Okay, which would help us in calculating the LCA. So this is basically the timeline. Okay, how the LCA had developed. So in 1969, the Coca-Cola scientists in Coca-Cola tried to find out the perform a multi-criteria study. So that was done by REPA, that is Resource and Environmental Profile Analysis of Coca-Cola in USA. Okay. So after that, in 1984, the EMPA, which is Swiss Federal Laboratories for Material Science and Technology, so they prepared an environmental report on packaging. Okay, for Switzerland. Then after 7 years in 1991, CITEC, okay, so that is Society for Environmental Toxicology and Chemistry. So they conducted first workshops, okay, related to life cycle assessment. And then after some years, the first European guidelines on eco labeling was published. Okay, so after a few years from 1991, first European guidelines on eco labeling was published. In 1997, a book was published in life cycle assessment, and from 97 to 2000, the ISO, okay, that is the International Organization for Standardization. So they developed standards, okay, which was published as a code ISO 14040. Okay, so that is basically the code for life cycle assessment. So they developed that code, and they published in between 97 to 2000. And in 2000 also, the Eco Invent Center. Okay, so that is the Eco Invent database from Switzerland. So that was also established in 2002. So the UNEP, okay, so United Nations Environment Program. So they also accepted the standards. Okay, they also accepted the standards and respected them, and also encouraged everyone to adopt them. And in 2007 there was a launch of European LCA platform. Okay, so that was basically European platform on life cycle assessment. And in 2010 the social LCA guidelines were published. So that was basically the life cycle analysis guidelines for the society. Okay? And thereafter finally it was found, till now it was found that various works have been done, such as the International Reference Lifecycle Data System, okay, ILCD handbook, and various other new new databases, as well as books, as well as softwares have emerged, okay, such as OpenLCA, SIMA Pro, okay. So various work is going on, and many countries have developed their own databases, okay, which was pioneered by Switzerland. So following them, many countries have developed their own databases. So that is a very important step towards life cycle assessment. So now let us go through the ISO framework. So if we go to the ISO framework, so basically that is the framework has been prepared prepared and published in ISO 14040. So they suggest four. It has four categories, as we have discussed initially. So the first is goal and scope definition. The second is the life cycle inventory, which is LCI. Third is life cycle impact assessment, which is LCIA, and the fourth is interpretation. Okay, and all of them, okay, details about them has been published in ISO 14044. So the framework of the guidelines have been published in ISO 14040, and the details of all the topics, okay, all the topics inside the framework have been published in ISO 14044. Okay, so that is mainly the applications, okay, how to apply the life cycle, okay, as per ISO framework. And it has been found to be an iterative method. Okay, so that means the collected data may lead to the modification of the scope of the study, as well as the goal itself can also be revised. Okay, so nothing is fixed here. Okay, based on the data, based on the assessment, based on our quality of thinking. Okay, based on our capability, we have to change it and revise it and modify it and amend it as much as possible to find out a quality result, get out a quality result, because choices are unavoidable. So the goal is the what and the what for. Okay, so why we are doing it, why we are doing it, and what we are doing it. Okay, so that is the goal. The goal must clearly define the object, the reason, and the intended application of the study. And examples from ISO 14040 are, for example, identifying opportunities to improve the environmental performance of products at various points in their life cycle, informing decision makers in industry, government, or non-government organizations. Example, for the purpose of strategic planning, priority setting, product or process design or redesign, the selection of relevant indicators of environmental performance, including measurement techniques, uh, as well as marketing. That is, example, implementing an eco-labeling scheme, making an environmental claim, or producing an environmental product declaration. Okay, so these are some of the examples of how the goal must clearly be defined, okay, as per ISO 14040. And one more goal is the for who. Okay, so for whom we are performing this, that is also important. The goal must clearly define the intended audience of the study. Okay, that is who will use these results, as we discussed. So it will the interpretations will be different for different audiences. Okay, so examples of link between audience and application is, for consumer, for example, they will try to differentiate functionally equivalent products to make more ecological choices. Okay, in terms of manufacturer, they will be looking for a way to reduce the impacts associated with its products to communicate their environmental merits. In terms of government, they will try to refine environmental legislation and elaborate incentive measures. Okay, so for every audience, say for example consumer, manufacturer, and government, the results interpretation will be different. So therefore we can say goal is equal to guide for the study. Okay, so therefore the goal will guide the depth and scope of the study. So it will define the systems, okay, that needed to be studied. It will define the functional unit and reference flows. It will establish the system boundaries. It will uh, it will set the initial unit processes inclusion criteria. Okay, it will mark the allocation rules. Okay, it will suggest the inventory data quality requirements. It will predict the LCIA method, that is impact assessment method. And it will also predict the need for a critical review. Okay, so these are the guide, like the goal will itself act as a guide for the study. Okay, and the function is basically the starting point. Okay, so in defining the function, we need the functional unit, that is the calculation reference. Okay, so what is required? Okay, what is the specification basically? But like what is the value specification in terms of value we want to achieve? Okay, for the product. Okay, and the system boundaries basically include the included unit processes, as I showed you. So it will include the processes and the unit processes. Okay, so not always easy to identify the function of the system. Some systems may be multifunctional. Okay, so that is the main issue. Okay, so the choices are unavoidable. Okay, so you have to select the correct choice. Okay, the quality of the choices matter a lot, because it is not easy to identify the function of the system always, and some systems may be multifunctional. Also, we need to differentiate between the primary and the secondary function, that is the specific and the generic function. So our idea should be to go for the specific function. Okay, so what is, for example, in the bulb thing, we need to find out which is better. Okay, in terms of the intensity for a certain period, that is 700, for example, 700 lumens for 10,000 hours. So that is the specific purpose. Okay, the secondary purpose is, as we discussed, it can be heating, it can be ambience. Okay, so that is not that much important. The main specific purpose is the main goal, primary. And in comparison, the systems must have the same functional performance. Okay, that is the same functional unit, then only we will be able to find out what is the LCA. Okay, so we have to take the same functional performance, same reference, then only we can calculate. Okay, otherwise the results will not be correct. And what is reference flows therefore? So this is the, as we discussed, it is the amounts of products, that is the elementary flow. Okay, necessary to fulfill the amount of function specified by the functional unit. So to achieve the specification as per the functional unit, what is the amount of products necessary to fulfill them? Okay, so what must be purchased in order to fulfill the function or the functional unit? Okay, so it will be different for each compared system, often related to the functional unit by key parameters for the optimization of the system, such as product life, number of uses, amount of matter energy used, that is efficiency. So it is a function of all those, that is reference flows. And what is unit process? So basically, it is a subdivision of the product system, assuring a unique or a group of activity operations. So it is basically a subdivision of the processes. Okay, which assures a unique or a group of activity uh, or operations in the product system. Okay, so subdivision of process, which basically refers to a unique or a group of activity operations inside the product system. Okay, and there can be two types of flows. Okay, that is inputs, outputs. There can be two types. One is the elementary flow, which we discussed initially, input, output, in inflow and outflow. And one is the intermediary flow. Okay, which is also called the economic flow. So intermediary economic flow is basically linking to unit processes. Okay, so that is basically the intermediary economic flow. So one or more represents the function of the unit process. Okay, so it represents basically the function of the unit processes. And the elementary flow is basically linking the unit process with the environment. Okay, so now when we talked about the inflow and outflow, we are basically that inflow and outflow basically was from the environment. Okay, so inflow was basically coming from the environment to the process, and outflow was basically going from the process to the environment. Okay, so that is basically environmental intervention. However, in intermediary flow, there always the flow was between two unit processes. So as you can see in this example, so unit process 1 to unit process 2, this is the intermediary flow, linking UP1 and UP2, that is unit process 1 and unit process 2. And in this case, this is the elementary flow to UP1 and elementary flow from UP1. So this is inflow, this is outflow. Okay, so both from and to the environment. Okay, so that is the elementary flow. So that's what we also discussed initially. So all processes, in theory, all processes required to fulfill the function should be included. So function is what we want to achieve, and to fulfill that, these are the processes: resource acquisition, manufacturing, distribution, use, and end of life. Okay, and they have been outlined by a dotted line boundary, which is the system boundary. And these are the flow of elementary elements, and this is the outflow of elements. So this is the elementary flow. Okay, So in terms of natural resource extractions and emissions in air, water, soil, as well as other environmental interventions. So that is, this is theoretical, okay, and practically, as much for certain product, as much as we know about its in-depth requirements, we will be able to prepare a detailed chart, okay, which lists all the flows, processes, unit processes that are available, okay, and thereby prepared a adequate inventory. So that is the requirement, that is the idea. So with this, let us finish, we have finished the fourth week lecture, okay, fourth week lecture notes, lecture class. So now let us try to understand it further through solving a few problems. So let us see how much we have understood. So first problem is, which of the following stages not included in ISO 14040 framework for life cycle assessment? Is life cycle impact assessment LCIA, B is goal and scope definition, C is life cycle enhancement LCA, or D life cycle and inventory LCI. So out of this four, which is not included in ISO 14040 framework for life cycle assessment? Is it A, B, C, or D? So if you see the ISO framework, if you remember this, so that has four categories: goal and scope definition, life cycle inventory LCI, life cycle impact assessment LCI, and interpretation. Okay, so LCI is present here. So three, so it is not the correct. Goal and scope definition is number one, so that is also available. LCI life cycle inventory, so that is also available number two. So LCE, life cycle enhancement, is not available. So C, life cycle enhancement, is the correct option. Okay. Second question, elementary flows involve the input and output relation between what? A, between two unit processes and represents the function of unit process. B, between two system boundaries and represents connection among systems. C, between system boundary and impact category, and represents the potential of impact from the system boundary chosen. And D, between environment and unit process and represents the environmental intervention. So what is correct from out of A, B, C, and D? So if you remember, elementary flows indicates the input and output relation between environment and unit process and represents the environmental intervention in terms of input taken into and output sent out of the system boundary. Okay, so that is basically the D option. Okay, and between environment and unit process and represents the environmental intervention. So D is the correct option. So as you can see, D, between environment and unit process and presents the environmental intervention, is the correct option. Third question, what is the significance of impact category and damage category in impact assessment approaches? A, damage category causes more severe effect than impact category. Uh, B, damage category is only cause considered when impact category could not evaluate actual impact. C, damage category is assessed by weighing the impacts from impact categories and indicates the ultimate harm to environment and human. D, none of the above. A, B, C, D, which is the correct option. Okay. So if you remember about this flow diagram, so we can see here that it is dependent on the impact category, right? So damage category is assessed by weighing the impacts from impact categories. So this was the midpoint, this is the endpoint. So it is assessed by weighing the impacts from impact categories and indicates the ultimate harm to environment and human in terms of a single score. And one impact category can lead to one or more than one damage category. Okay, so depending on the potential and the ability requirement, so it can have more than one damage category. Okay, so therefore, C is the correct option. That is, damage category is assessed by weighing the impacts from impact categories and indicates the ultimate harm to environment and human. Okay, so C is the correct option. So as you can see, C, damage category is assessed by weighing the impacts from impact categories and indicates the ultimate harm to environment and human, is the correct option. Fourth question, which statement dictates the relation between functional unit and reference flows? A, reference flows indicates the amounts of input necessary to fulfill the amount of functions specified by the functional unit. B, reference flow provides the basis for functional unit determination. C, reference flow has no correlation with functional unit. D, reference flow is the functional unit multiplied by impact factor. out of A, B, C, and D, which is the correct option. So if you remember, so functional unit is the specification or need for the product to achieve uh, certain tangible output. Okay, so certain tangible performance, the requirement of some performance is the functional unit. Okay, that is a specification, and to achieve that, what are the inputs and the flows required? So that is basically the reference flow. So that means it has correlation. Okay, so C is not correct. It is a functional unit multiplied by impact factor, so that is also not correct. It provides the basis for functional unit determination. No, so functional unit is independent of reference flow. So it is first it is found out, and then to achieve that we select the reference flow. Okay, so it does not provide the basis. So B is also wrong. So reference flows indicates the amount of input necessary. So that is the elementary flow necessary to fulfill the amount of function specified by the functional unit. So this is the correct option, A. So as you can see, reference flows, amounts of products necessary to fulfill the amount of function specified by the functional unit. What must be purchased in order to fulfill the function? So this is the correct option. So A is the correct option. So as you can see, A, reference flows indicates the amounts of input necessary to fulfill the amount of function specified by the functional unit is the correct option. Fifth question, inventory may count hundreds of different inputs and outputs to the system, which becomes very hard to process and interpret. uh, how is this issue taken care of in LCA? Okay, so A, neglecting the processes which contributes to less than 5% of environmental load. B, neglecting the processes which contributes to less than 0.1% of environmental load. C, solving complex relations by using machine learning. Or D, solving complex relations by using supercomputers. So out of A, B, C, or D, which is the correct option? So how the issue related to uh, like counting hundreds of different inputs and outputs to the system taken care of in LCA. So if you remember, we discussed it properly. So we neglect the processes which contributes to less than 0.1% of environmental load, if you remember. So B is the correct option. So it is also written, inventory may count hundreds of different inputs and outputs to the system, so which becomes very hard to process and interpret. This is taken care by neglecting those processes which contributes to less than 0.1% of environmental load. So basically, this neglecting the processes which contributes to less than 0.1% of environmental load. So B is the correct option. So sixth question, which of the following is a common database used during LCA? A, Econscious database, B, Ecologistics database, C, EcoCycle database, or D, EcoInvent database? Out of A, B, C, and D, which is the correct option? So we have properly discussed this. So this should be the EcoInvent database of Switzerland. So which is very globally accepted and standard database. So it is the most common database used in LCA. That is EcoInvent. So it is a central database made from various institutions combined, and it is from Switzerland. Okay? So uh, the EcoInvent database is the correct option. Seventh question: electric vehicles (EVs) are not zero emission vehicles. Why? A, batteries needs to be recharged by electricity, and electricity production as air emissions. B, batteries emits radiation like nuclear waste. C, EV has a non-zero gasoline indicator installed in the car. D, batteries contain heavy metals. Production and disposal of these metals is associated with environmental emissions. So out of A, B, C, and D, which are the correct options? So definitely batteries does not emit radiation like nuclear waste. Okay, so this is not correct. Um, so B is wrong. And batteries, EV has a non-zero gasoline, so it does not have a non-zero gasoline indicator installed in the car. So this is also not correct. So batteries need to be recharged by electricity, and electricity production as air emission. So this is correct because most of the electricity production is from non-renewable resource such as thermal power production still till today. And this is A is correct, and batteries contain heavy metals, so that is correct. Lead is there, and the production and disposal of these metals is associated with environmental emissions, so that is also correct. So D is correct. So A and D are the correct options. So that is also written here. Electric vehicles are fully powered by batteries. Batteries of this type need to be recharged, and recharging happens with electricity. So electricity production is air emissions, and also batteries may contain heavy metal and rare earth metals, Mining of these metals and end of life recovery requires further processes which results into emission. Okay, so that's why A and D are the correct options. So as you can see, A, batteries needs to be recharged by electricity, and electricity production is air emissions, and D, batteries contain heavy metals, production and disposal of these metals is associated with environmental emissions. So A and D are the correct options. Eighth question, choose the correct options. A, life cycle impact depends on intermediate flow. B, the goal must clearly define the intended audience. C, incineration of waste which contains heavy metals instead of landfilling them is shifting the problem in spite of solving the problem. D, environmental impact assessment for a new activity provides the results on a global scale. So out of A, B, C, and D, which are the correct options? So life cycle impact depends on, so it depends on elementary flow. So inflow and outflow of elements, okay, not intermediate flow, because that is a flow between the unit processes itself. So A is incorrect. Okay. B, the goal must clearly define the intended audience, so that is correct. So for for different audiences, the interpretations will be different. Okay, so it must clearly define the intended audience, the goal should define. So B is correct. See, incineration of waste which contains heavy metals instead of landfilling them is shifting the problem in spite of solving the problem, so that we discussed. So it is a shifting of the problem. So instead of landfilling the heavy metals, we are just burning them. So we may have remove the waste, but that has gone to the air. So that is again in itself has become a new problem. So C is correct. So that is shifting the problem. And D, environmental impact assessment for a new activity provides the results on a global scale. That is true, because all the indicators which we are using, that has its implications globally. Okay, it is not a regional or local. The effects are not regional or local. What will be we will be doing, it will have effect globally. All the indicators have all the indicators associated with environmental impact assessment have the implications globally. So B, C, and D are the correct options. So here it is written also, life cycle impact depends on elementary flow, not intermediate. The goal must clearly define the intended audience. Incineration of waste which contains heavy metals instead of landfilling them is shifting the problem in spite of solving the problem. And environmental impact assessment for a new activity provides the results on a global scale. Okay, so B, C, and D are the correct options. Ninth question, what are the features of LCA? A, LCA provides the global perspective by assessing complete life cycle of a product, project, process, service, and includes all environmental impacts. B, all LCA studies have a common defined goal as instructed in ISO framework. C, the single score for indicating the impact is based on value choices and choices are unavoidable. D, LCA is suitable to calculate cost and increase profit. So out of A, B, C, D, which are the features of LCA, which is correct. Okay, what are the features of LCA out of A, B, C, D? So LCA provides the global perspective by assessing complete life cycle of a product, project, process, service, and includes all environmental impacts. So that is true. So he is correct. B, all LCS studies has a common defined goal as instructed in ISO framework. So that is wrong. So the goal depends on the audience, target audience. So it can be common. Okay? So B is different. B is wrong. C, the single score for indicating the impact is based on value choices, and choices are unavoidable. So that is true. So the score will be dependent on the choices we take. Okay, so the indicators we choose, the midpoint indicators, endpoint indicators, the weights, okay, and the interpretation. So it will depend everything, and those are based on our choice. There is no scientific reference to that. So uh, choices are unavoidable. We have to take quality choices. So C is correct. And D, LCA is suitable to calculate cost and increase profit. So that is wrong. It is only environmental impact assessment. Okay. So for socio-economic and financial assessment, there are some other tools. Okay. So this is incorrect. So A and C are the correct options. So that has been written here. So key features of LCA: complete life cycle plus all environmental aspects, global perspective, complex. So there is problem of transparency. Depth of detail of LCA varies, and it depends on goal of the study. Resource needs in terms of time, money, software tools vary, and choices are unavoidable because it is subjective. Okay, so for various And for various people there will be various choices, and the quality of the choices matters a lot, and no scientific basis to reduce results to single score, so that depends on the value, that is quality of the choices. So in C are the correct options. Last question: what are the limitations of LCA? A, only environmental impact is accounted, socio-economic aspects are not assessed. B, LCA depends on data quality. C, LCA provides global perspective. D, all of the above. A, B, C, and D. What is the correct option? So, and and only environmental impact is accounted, socio-economic aspects are not assessed. So that is true. Okay, so that is a limitation of LCA. Okay, so that is, so therefore A option is correct. B, LCA depends on data quality, so definitely, so higher will be the quality of the inventory, the stock of data, so better will be the analysis and the score interpretation. So B is also correct, so that is also a limitation. Okay, the C LCA provides global perspective. Okay, so that is a good thing. Okay, that is a benefit. Okay, it gives a global idea of the assessment. Okay, and of the environmental impact for a product. So that is a benefit, not a limitation. Okay, so therefore this is C is incorrect, and because C is incorrect, D is also incorrect. Okay, so A and B are the correct options. Okay, so one, it depends on data quality, which is a limitation, and secondly, it is in environmental impact only, accounting of environmental impact, no socio-economic aspects. Okay, so as you can see here, limits of LCA: only environmental aspects, social and economic aspects with other tools, inventory, not all processes and flows, data quality is important, and impact assessment, chosen impact categories, available characterization models, relevant inventory data. So these are some of the limitations. Okay, so A and B are the correct options. Okay, and only environmental impact is accounted, socio-economic aspects are not assessed, and LCA depends on data quality. Okay, so these are the limitations. So A and B are the correct options. So with this, we come to the end of today's discussion on the 4-week course lectures. So let us meet next week to carry on with the discussion on the 5th week lectures. Okay. So with this, I would like to end today's presentation. Thank you.